fortunate to have Nick Tucci with us here today from URS, and he's going to talk to us about the super cleanup of the mega Superfund Uber mess in Butte, Montana.
Thank you, everybody. I have a recent move to Chico, California. Actually, I moved here in July of this year. I've been here for, what is that, 4 months now almost? Yeah. And so my first day at URS actually was the day that AECOM bought out URS. So I literally walked into the place. My supervisor, who's sitting right here, came up to me and goes, "Have you been paying attention to the news?" And I go, "No, why?" He goes, "URS got bought out by AECOM." And I thought I was going to have to do an about face back to Butte, Montana. But 4 months later, I'm still getting a paycheck, so I'm still here. I spent the last 10 years of my life in Butte. I wasn't working for URS at the time. I was with the Montana Bureau of Mines and Geology. They hired me right out of graduate school. I got my graduate degree in Butte at Montana Tech University, studying the Berkeley Pit. I did a bioremediation potential experiment on the Berkeley Pit water. There is no bioremediation potential at the Berkeley Pit. So I'm going to talk to you a little bit about that site today. A Superfund MegaSite is basically any site that's on the national priority list where remedy has cost over $100 million. And we're well over $100 million on the Butte Area Superfund Site. They're broken up into operable units, and just on one operable unit that I'm going to talk to you about today, there's been about $120 million spent on that site. So it's pretty big, it's pretty massive, and I'm just going to dive right into it because I got a lot of slides. So here we go. I've never done an outline before on a presentation, but I skip around a lot here, and I just wanted to kind of organize you guys into what I'm going to talk about. I'm going to cover acid mine drainage, which is the main problem in Butte and most of southwest Montana. I'm going to define what Superfund means. I'm going to give you a little bit of a history of Butte and Silverville Creeks. And then I'm going to cover 2 operable units of the Butte Area Silverville Creek NPL site. And that's streamside tailings, which is the physical removal of the contaminated tailings along the stream. And the Butte mine flooding operable unit, which is the Berkeley Pit. And I like the juxtaposition of these 2 sites because they pretty much cover the 2 kinds of remedy that are going on in Montana. You can either dig it up, get rid of it, move it to a repository, or you could contain it, keep it, protect human health and the environment, contain it, and pump and treat it forever. And so that's pretty much what's employed here at the Butte Mine Flooding Operable Unit. So I really like the contrast of those 2 sites, and that's why I chose to talk about them today. I can't cover the whole site. It's just too massive, and I could talk for days about it, and I won't. So acid mine drainage is basically the catch-all phrase. It's also been termed acid rock drainage. It's known colloquially as yellow boy or ochre, and it's basically the acid waters that are produced by underground mines and surface mines. And so these are 2 pictures of the Berkeley Pit, and you could pretty much look at this stuff. And the red comes from the iron that is dissolved in the water, forming secondary minerals, and it's pretty acidic stuff. And my thesis advisor gave me a piece of advice that I'm going to talk to you guys about today. I'm going to share with you guys today, and that's never be afraid to put a well-balanced geochemical equilibrium reaction on your presentation. It sexies up your presentation. His words, not mine. But this is the initiation reaction for acid mine drainage. It's the reason why acid mine drainage happens. If you guys are familiar with the fire triangle, you need 3 things for a fire to occur, and that's a source, fuel, and oxygen. And so basically it's the same with acid mine drainage. You need 3 things for acid mine drainage to occur. And that's you need the source, which is pyrite, iron pyrite, also known as fool's gold. You need oxygen, and you need water. And those 3 things combined create sulfuric acid and dissolved iron. Now, for every 2 moles of iron pyrite that are weathered, 4 moles of acid are produced, and that lowers the pH of the surrounding environment. Now, when you lower the pH of a surrounding environment, you increase the acidity of that water, and that leaches out more minerals that are in the wall rock or the host rock, which it's kind of like salt dissolving in water when you put salt or sugar and water at your dinner table. And so that's pretty much it. Now the definition of Superfund. Superfund was originally established as a fund, as a tax. They taxed corporations that were most likely to generate contamination. That went away in the early 2000s, and now everything pretty much comes out of the general fund. But it was an act passed by the Congress that basically gives the EPA the authority to clean up polluted abandoned sites and hold accountable certain potentially responsible parties. The National Priority List is a list of sites that are the largest priority to the EPA. There's a whole system and series in which these sites are ranked. I'm not going to go into that. I will put you all to sleep. But it's intended to guide the EPA in determining which sites warrant further investigation. Nationally, there are 1,322 sites. There are 16 sites in Montana. Does anybody venture to guess how many sites there are in California? On the federal MPL list?
A lot.
A lot. There are 97 sites on the MPL list for California. 13 sites in California have been delisted, meaning they've cleaned them up to the point where they're no longer on the priority list. There's never been a site in Montana that has been delisted. They're 30 years of this, and they've all stayed on the list. There's a lot of technical issues associated with cleaning up the contamination in Montana. And so here's the site. It stretches from Butte, Montana, which is in southwestern Montana, all the way to Missoula, Montana. This area right here in yellow is the Silverbill Creek Butte Area National Priority List site. There are 5 other sites associated with it. There are 2 in Butte. There's 1 in Anaconda. There's one in a couple in Missoula, and together, all of those MPL sites form the Clark Fork Basin Superfund area. That area is the largest Superfund area in the country. It covers about 122 miles of river and stream length. And so Butte gets a bad rap because you go there and you see the Berkeley Pit, you see this scarp of just total environmental devastation, and you think, God, what a dump. There is nobody on earth that is more proud of their community than Butte, Montana, and it's because they helped build America. And so it was termed the richest hill on earth because they produced over 23 billion pounds of copper, 4 billion pounds of manganese, 5 billion pounds of zinc, 1 billion pounds of lead, 300 million pounds of molybdenum, 700 million ounces of silver, 3 million ounces of gold, and together that's over $100 billion in money. And so during the Industrial Revolution, it led the way, it helped light America, and it was a major part of the reason why America has been so successful. And the people of Butte are very proud of this. And you can't really take that away from them, but they're dealing with a lot of waste. This was a picture that was taken in the 1940s, and it just shows there's waste rock piles, and down here there's just tailings all over the place, and there's smelters everywhere you can look and the contamination that was formed in Butte is responsible for all the contamination seen between Butte and Missoula. So they're dealing with waste rock, tailings, and slag. Waste rock is a product of the mining. You got to dig down to the ore, and that's what all this stuff is. And then tailings and slag are products of the milling and refining process. And tailings are by far, that's the concentrate, and so there's a lot more pyrite in that stuff. And it is probably the largest contributor of acid mine drainage for the Silverbow Creek area. And it just, you know, I mean, you go to Butte, most people think it's ugly. Now, I personally have a skewed opinion. I think the Berkeley Pit is the most beautiful place on earth, but it, you know, I mean, most people think that Butte's a big hole, and that's because there is a pretty big hole there. They have a very large open pit mine that has since flooded. That's a picture of the Butte Berkeley Pit in 1972. It is 1,700 feet deep. It's about 2 miles in length and 1.5 miles in width. And then there are also about 10,000 miles of underground mine workings in Butte. This is the Berkeley Pit right here, and then these are the overlay of all the mine workings that have occurred over the 100 years of mining. This is what Butte looked like in 1864, or well, the 1880s. So in 1864, gold was discovered in Silverbow Creek, and miners rushed into Butte, and they started placer mining. And then in the 1870s, they discovered very rich veins in Butte. There was 30-foot thick veins of 50% or greater copper ore. And so for the next 100 years, they started mining out those veins, and doing it by underground stope mining. Then by the mid-1850s and 1855, the rich veins started to play out, so they wanted to go after the lower grade ore, so they started open pit mining. That is one of their first cutbacks in the Berkeley Pit. This picture was taken in 1957, and then that's what it looked like in 1979. So this is a hard segue. I didn't know how to make this segue. I'm going to start talking about the streamside tailings aquifer unit, which is the physical removal of tailings along Silverbow Creek, which actually has nothing to do with the Berkeley Pit. So the creek itself was used as an industrial sewer. It was a 22-mile long stretch. It was the headwaters of the Clark Fork River, which is the headwaters of the Columbia River. And so this is a picture right here of the creek. They routed another. This picture is one of the smelters that were in town. That is the Butte Reduction Works. It was one of the larger smelters in town. And then these are retention walls, and they're retaining mine tailings, just straight up mine tailings. And so they would decant the mine tailings right next to the creek, and that obviously had very profound negative impacts on the water quality. In 1904, downstream ranchers actually started to sue the miners, and this picture was taken around that time as one of the pictures for the lawsuit. This is a picture of Silverbow Creek. This is aggrandizement. They were dumping so much tailings into the creek that it started to dam up, and massive flood events were starting to occur. So, I think I talked about all this. The city of Butte did begin to use it as just for the raw sewage in the 1870s, and so all the way up till now, you have people referring to Silverbow Creek as either Copper Creek or Shit Creek. And so, I want to go back to this picture for a second, and I want you to imagine for a second, as far as your eyes can see on the left of this photo, and as far as your eyes can see to the right of this photo, you have tailings that are just piled up and actually above the stream bed. So you have millions and millions of cubic yards of acid-generating material sitting right there, right next to the creek. So what do you think would happen if a 100-year flood event occurred at this location? It's just going to take all that stuff and wash it right into the creek, and it's going to go downstream. And that's exactly what it did. This is the 1908 flood. That is the Milltown Dam reservoir right there. It was just constructed in 1907, and it was up for about almost a year when this flood happened. It was a 100-year flood event. USGS went and calculated this discharge right here, and it was about 48,000 cubic feet per second. The largest discharge ever recorded since that time has been about 20,000 CFS. So it was more than double the highest flow ever recorded. And it transported a lot of sediment. And you could see it along the stream bed. This picture was taken in the early 2000s, and it just shows the floodplain of Silverbow Creek and just tailings everywhere you look. Now, nothing's going to grow in acid-generating material, so that's what you saw for 120 miles. I think I covered all this. This is a picture of Ramsey Flats. That's 12 feet of tailings just sitting in that cutbank right there. And so the fluvial action of the creek, it was transporting and retransporting this stuff, the massive fish kill-offs. Silverbow Creek, from the turn of the 20th century all the way up to really late 1980s, 1990s, was a dead stream. There were no macroinvertebrates, there were no fish species living in the stream at all. It was degrading the upper portion of the Clark Fork River all the way down to the Idaho border. And so it was having pretty profound impacts on everything. Now prior to this, there is a lot of evidence that this was very rich, fertile ground. The Indians used this area as a pretty good fishing habitat. It had bull trout in it. Bull trout are a species of concern in Montana. There are no bull trout in it anymore. But this is a close-up, just looking at the floodplain of Silverbow Creek. And so in 1998, the state of Montana sued Atlantic Richfield Company for $86 million. At that time, the most you could sue a company for was about $100 million. So they really were not able to get anything from that at that time. So in 1998, 1999, the settlement went through, and they started to work in Butte on the Colorado smelter and the tailings pond that are there. That was the largest tailings impoundment area in Butte. It was about 2.5 million cubic yards that they removed. And I'm going to get to that in a little bit. They spent up to about $120 million so far on this site. The restoration is, I'll get to that. Actually, I have a slide coming up. And they have about roughly $40 million left over for funding. Still. They've lived off the interest, basically, for those 20-some years. So, this is Butte, Montana right here. This is Montana Street in Butte, Montana. This is the start of Silverbow Creek right there. This is a picture in the 70s. And Silverbow Creek started right there, and then it came through here, and then originally it went through the Colorado tailings right there. But they routed it as a sort of a way, an intermittent step. They routed it around the tailings impoundment so that they wouldn't get any sediment discharge during runoff. By 2000, they turned that area, they removed those tailings, 2.5 million cubic yards. They put them into a repository, and they created the Butte treatment lagoons. And those lagoons are basically a lime treatment system, settlement ponds, and that treats all the contaminated groundwater that is left in Butte. And so to do remedying along a stream bank, it's pretty complex, and there's a lot of technical aspects to it. They had to dewater the stream, and so they would put the stream into a pipe and route the stream around the site that they were remediating, and then they would have to dewater the groundwater that was discharging into the stream. And so back here you have these large groundwater interception trenches that they're pumping out of, and they're putting them into these big tankers. Now the groundwater was contaminated there, so they would have to fill up those tankers and send those tankers off to treat that water. So it was a large technical hurdle. In Montana, they don't have permafrost in Montana, but it's pretty close. We call it perma-winter. It's winter all the time, and it's pretty difficult when things don't dry up to work in this environment. The next step was the removal. It was pretty straightforward. They set removal standards and action levels. For instance, the action level for copper in the soil was about 1,000 parts per million. And so they would basically dig test pits and step out every 50 feet until they didn't have contaminated sediment anymore. And then they would remove everything in between there and that point. They would take the, now mind you, there's quite a bit of stream, there's 120 miles. For Silverbow Creek there's only 22 miles, but there's 120 miles of contaminated area. So they devised a plan to put it, scoop the tailings up into haul trucks, take the haul trucks to the nearest railroad bed, and then rail all the tailings to an area, a repository known as Opportunity Ponds. This is Opportunity Ponds right here. It's 5.5 square mile complex, and it is the permanent home for all of those tailings. And then they redesigned and reconstructed the channel. I had nothing to do with this process, but basically they had to stabilize the bank, and they did that with this burlap right here. And then they would come in and revegetate. And the first thing they need was clean topsoil. And this was one of the more expensive aspects of remediation right here, is finding clean topsoil. The burrow pits were miles away from the site, and hauling that back and forth was probably the biggest cost to the project by far. They would spread about 18 to 24 inches of topsoil, which was amended with an organic component, because you need organics to get vegetation to grow. And they would seed. That's them seeding right there. And then they would hand plant. And they actually hired the Salish Kootenai Native American tribe out of Butte Montana to do this work. And they did a great job. This is Silverbow Creek before remediation. And you can see this is just on the west end of Butte. This is looking downstream towards Anaconda from Butte. And you can just see there's waste rock piles and they're all over the place. And so this is what it looked like during construction. And this is 4 years after. This picture was taken in about 2007, 2008. Now you go down there, and I wish I had a picture, but I looked all over for a while and I couldn't find one. But the phreatophytes have taken over, and this area looks actually pretty nice. The one problem that they have is all of this were non-native grasses, and so the state of Montana is using restoration dollars to go back in and start planting native plant communities to try and bring this place back to what it was before. Does anybody know what the difference between remediation and restoration is? Remedy is bringing, remedy is cleaning up the impacted area to the point where it meets human health standards to protect human life and the environment. And that's basically doing what you can to make sure that you're doing that. Restoration is actually bringing the environment back to the point where it was before humans interacted with it. Remediation in Montana is pretty difficult. There's a lot of technical issues associated with it, but restoration is next to impossible. It's a much harder task than remedy. And so, where they're 99% complete with the removal, they spent up to about $120 million. They're going to be done here next year. They turned 22 miles of original stream bank into 30 miles of stream bank, and they're not done. The restoration effort's taken over now. They're going to be upgrading all of the sewage plants. They're working on tributaries, trying to stabilize sediment. They just established TMDLs for the area. And the success of this particular operable unit has been remarkable. 6 cold water species have reestablished itself in the creek from zero. Every year the Montana Fish, Wildlife and Parks comes in and they do fish surveys, and it's become great spawning habitat for the West Slope cutthroat trout, which is another species of concern in Montana.
Any bull trout?
No, your bull trout are just, they're in a lot of trouble in Montana, mostly because of climate change, but also because of habitat degradation. And so you still get bull trout in Montana, it's just in areas like Glacier National Park and the higher alpine lakes.
Where there aren't people?
What's that?
Where there aren't people?
Yeah, pretty much. So, and for the first time ever in the history of Silverbow Creek in 2012, this was a huge event. The Fish, Wildlife and Parks established fishing regulations for Silverbow Creek, so people can now fish in that pond. They still can't eat them, but but they can catch them. So now I'm going to transition into the Butte Mine Flooding Operable Unit, which is basically the Berkeley Pit. The Berkeley Pit changed my entire perspective in life. I moved there in 2002, and it's just it's an unimaginable problem, and you just can't really remedy it. So the next step is you have to leave the waste in place, and they pump and treat it forever. They're containing the waste, they're protecting human health and the environment through institutional controls, and they're just basically going to do this in perpetuity, which means forever. It's in Montana, it's probably the most notorious site because its features are so conspicuous. You have the Berkeley Pit, which is right there. You also have an active mine next to it. That's the Continental Pit. They're still mining in Butte. The Continental Pit and the Berkeley Pit are separated by the Continental Fault. It's a normal fault line, and because of that fault line, you have completely different wall host rock over here than you do over here. You have a lot more carbonates in this wall rock, a lot more neutralizing potential to that ore body, and so it'll never generate. Well, I'm not going to say it'll never generate, but it's going to, the water that when they close that pit down, the water generated is not going to be acidic. It's going to be alkaline. And then you have the Yankee Doodle tailings pond. Now, the active mine is actually generating tailings from this mine, putting it through by putting it through their concentrator, and then they're taking those tailings and they're keeping them under the water. Now, I told you that there's the fire triangle to acid mine drainage. So if you keep tailings saturated under the sediment, under the water, and you keep the pH high, you're eliminating oxygen. So you can't oxidize those tailings. And so that's kind of what their closure is for that portion of the site. The Yankee Doodle tailings pond is being retained by the largest earthen dam in the United States. It stretches from here all the way around to here. But it's really, I don't care how you come into Butte, it's the only thing you see when you come into Butte. And so it's very notorious. It's a tourist trap. People stop and spend time in Butte, Montana to come and see the Berkeley Pit. They actually charge people $3 to see the lake.
But they have former miners who lead the tours. I used to live there too.
It's correct.
And it is interesting to hear their tales.
It is.
Though it is atrocious.
It is. I gave an interview for NPR once, and the guy who does, I can't remember the name of it, but the thing he asked me, and literally, and I'm going to say it, I apologize if I offend anybody, but he said this, and I was taken aback by it, so much so that I gave the worst interview of my entire life. It was for Science Friday. It wasn't Ira, whatever that guy's name is, but he looked at me and he goes, the first thing I need to ask you is, what the fuck happened here? And I laughed and I go, well, that's not going to be on this interview, and I say that. That's the first thing I say, and then he played it and made me look like an idiot.
Well, it's interesting because one of the miners that I met was really glad that he was doing surface mining, so he was part of the Berkeley Pit, part of that. And his parents and his family always said, I don't ever want you underground, because they were a mile underground all day for their lives.
Yeah.
So this working in the Berkeley Pit was great.
Yeah. Yeah, it was much safer than working in the underground. And the underground is hot, it's humid, you get wet, you're soaked in acid water all the time, and it's just a terrible environment. It's dangerous, no matter how safe you could make it, it's dangerous. But back then it was 10 times as dangerous. And so when the Berkeley Pit came by, the one thing, the miners did fight it though. The miners fought it because it was going to reduce the amount of jobs. Because, it took 5 guys working underground to do the same job as one job amount. But I digress, sorry. And so, how did this happen? Well, they were mining, so they had a water table, they had groundwater that they needed to get rid of, so they started pumping. This is a cross section going through Butte, looking from east to this is an east-west trending cross section through Butte. This is the profile of the Berkeley Pit right there, and then this is the 10,000 miles of underground mine workings. These are vertical mine shafts, and these are the mine workings. They had these massive pump stations underground. This was at the 2,800 foot, and 2,800 means it's 2,800 feet under the ground. This is 3,900 feet under the ground. And so they had these huge pumping stations down here, and they were just dewatering this whole area. So basically they created a huge cone of depression, or it's basically a huge bathtub, so that they could get access to these mines. In a whole bunch of reasons, in 1982, the mine went under, and they shut off the pumps. They told nobody that they were shutting off the pumps, and they shut off the pumps on Earth Day in 1982. The miners rushed in, tried to get their stuff. They had all their stuff underground, and they couldn't even get to their stuff because they told nobody that they did this. And the water just started filling up. Now the pumps were down here, but it took a year for the water to reach right here. But once it hit the Berkeley Pit, that's a huge surface area that had to fill up. So the water just started filling up the Berkeley Pit. And so it's been filling up from 1983 until today. It's still filling up today. And so this is that same cross section looking at the Berkeley Pit. It took a year for 66% of the underground mine workings to fill. And now it's taken 32 years for 26% of the mines to fill. And there's still 8% remaining to be flooded. The Berkeley Pit opened in 1955. It was a porphyry copper mine. They turned off the water in 1982. The lake began to form in 1983 and it started filling up. This is 1,700 feet from here to its lowest point. And that's what it looked like in 1982. That's what it looks like today. So they established a critical water level for it, the point where they could let it fill up to where it'll still be safe. Now the Berkeley Pit is acting as the bathtub, the sink. It's the lowest point on the Butte Hill. You got all those mine shafts and contaminated water in the mine shafts that are all flowing towards that lowest point. And so it's acting as the point of collection for all those underground mine shafts. I like this photo, this picture, that's why I included it, but I can't spend much time here because I don't even know how much, we gotta get going. This is what Butte looked like before the Berkeley Pit. It was an intermontane fluvial stream. This was the East Ridge. The Continental Fault comes through here. Montana Tech is right there, by the way. That's pretty good school. This was the Butte Hill right here. This is where they started mining. So when they started mining the Berkeley Pit, they started working back this mountain. And they literally removed that mountain. And they filled in this basin with tailings and waste rock. I'm going to show you what that looks like. It was 1.3 billion tons of material. I don't have a way of actually explaining to you how much material that is, but it just filled in that entire valley. And then at the base of this is the largest earthen dam in the United States, and then the Berkeley Pit sits right here. And so the water inputs, it's a terminal lake. There are no outputs to the Berkeley Pit, except for evaporation. And so groundwater is filling up the Berkeley Pit at about 300 million gallons per day. The Horseshoe Bend treatment plant, which is the treatment plant that they built to treat Berkeley Pit water, is actually treating a spring that was used to flow into the Berkeley Pit. And they they generate sludge as a part of that treatment facility, and they dump that sludge back into the Berkeley Pit, and that's about 211,000 gallons per day. The horseshoe bend drainage, periodically it used to be allowed to discharge. It's just a spring at the base of the dam, which is behind the Berkeley Pit. And periodically it was allowed to discharge into the Berkeley Pit, but it was filling up the Berkeley Pit too fast at twice the rate. So they built the horseshoe bend treatment plant. They started treating the horseshoe bend spring, and then the mine actually uses that water as makeup water in their facilities. Precip, it's a high dry area. It's pretty much a desert. They get around 12 inches per year, and then they have a bunch of stormwater diversion channels. Stormwater is still a big issue in Butte. It's contaminated, so a lot of it they take and they allow to discharge into the Berkeley Pit. And the only water output is evaporation, which is greater than precipitation. And for a time, for about 10 years, I was Captain Nick Tucci of the USS Berkeley. That is the USS Berkeley right there. That is my two-man crew. We'd go out for a 4-hour tour. Prior to USS Berkeley, they monitored the Berkeley Pit with a helicopter. And now stability issues and with the way that the lake is filling up, there's some sloughage issues, some stability issues, so they are going to go back to the helicopter. So I could have been Airman Tucci of the, but that's, I'm not. But it exceeds just about every water quality standard, inorganic water quality standard known to exist. It's pretty nasty. It's about 800 feet deep. It's 41 billion gallons of acidic water. It's a terminal lake, very poor water quality. It's about 12 grams per liter of total dissolved solids. It has a pH of about 2.5. Wicked high iron concentrations, which give its nice red hue, which is the reason why I think it's so beautiful, but I think you guys are probably not enamored with it like I am. And so, part of my main jobs was we established a monitoring program. It was written up in this consent decree in 2002, and I was the guy that did all of that monitoring. And so I got there about here, and I missed all this, but my boss was there for all that, and he is known as Mr. Superfund in Butte because he pretty much started it all. I was Mr. Superfund Jr. And so, again, another part of my job, another part of my task was to ensure that that cone of depression was maintained. The Berkeley Pit remained the lowest point on the hill, and all that contaminated water from the surrounding environment discharged into the Berkeley Pit. These are potentiometric surface warnings right here. It shows groundwater potential, and so groundwater moves from high potential to low, and so everything is moving in this direction. We generate these every quarter. And so I'm going to talk to you a little bit about the critical water level. 5410 was established because it would be the lowest point that the Berkeley Pit would be allowed to fill up to, where it remains the lowest point on the hill. They put, and so they established 9 point of compliance sites, which are, the Berkeley Pit is not actually the point of compliance site for this. It's all the wells around, all the sites around the Berkeley Pit. And if you think of a point of cone of depression, your lowest point being the Berkeley Pit, anything out here is actually going to be higher. And so when at any point that these wells hit that 5410 mark, they got to turn on the pumps and they got to keep it at that level forever. And they're going to have to treat that water. And so if you really want to bore somebody in your presentation, you just put a hydrograph in your presentation. Hydrographs are basically a way to show rising water levels rising water level trends over time. And so these are 2 of those point of compliance sites right here. The x-axis shows time, the y-axis shows water level elevation. This is the point of compliance. The Anselmo and the Kelly are two point of compliance sites. One is the most distal, the Anselmo is the most distal to point of compliance site to the Berkeley Pit. The Kelly is the most proximal site. And this is what it looks like over time. The water has been raising at about a half a foot a month, which is about 6 feet a year. So those are the point of compliance sites, and then I'm going to overlay on that what the Berkeley Pit water level have looked like over time, and they've come in like that. They're lower than those point of compliance sites. And on average, the Berkeley Pit has been about 25 feet below the highest point of compliance site. So when this hits the 5410, they start pumping and treating. The Berkeley Pit's still going to be about 25 feet below that point. I'm going to talk about water quality of the Berkeley Pit a little bit more. There's so much copper dissolved in Berkeley Pit water that they actually mine the lake for copper. This process, known as iron cementation, was invented in Butte, Montana by a guy by the name of William Ledford in 1890. And here's another one of those sexy equations. It's basically, you take scrap metal, railroad ties, whatever, and you run the Berkeley Pit water over it, which has dissolved copper in it. And there's an ion exchange process that happens where elemental or iron gets replaced for the copper, so now you have elemental copper, and you go and you sell that stuff. And that's what this stuff is. This is an underground mine shaft, but water's running over this adit. There are these rails here, and there's so much copper in that water that copper is literally plating out on that road. And that's a close-up of it. That's kind of the technology that they use there. They've been doing that since about circa 2003, 2004. Mine companies made about $25 million off of doing it. Basically, they take deep Berkeley Pit water, they run it through these bins containing scrap metal, and then they return it to the surface water. And so you got this cyclic process going where you're returning deep Berkeley Pit water to the surface, and it has had profound impacts on the water quality. And I'm just getting ready to publish a paper on this with a co-author of mine. He's my advisor from graduate school, actually. But this is just an example. These are copper concentrations. This is a depth profile here. And this is copper concentrations. This is water depth. Surface is at the top. And then depth increases as you go down that. And these are concentrations over time. And so this is December of 2002. They started right around here in 2004, 2005, and you can see that copper concentrations are just decreasing at all depths. Now, you would expect that because they're removing the copper from the water. And so you would think, well, they're just replacing it with iron, so your iron concentrations are going to go up, right? That's not what is happening at all. Iron concentrations have decreased dramatically. They've gone from about 1,000 parts per million to about 200 parts per million. And so just lake-wide water quality impacts. And you know, I like giving this at mining conferences because it shows that sometimes mining improves water quality. Yes, sir.
Do you think that discovery was almost by accident? It was already happening?
It was by accident, actually. There was the Anaconda. Well, at that time, the Anaconda company consolidated all the mines, and they were discharging basically Berkeley Pit water to Silverwood Creek at that point. They were just discharging all this contaminated water straight to the creek because that's, you know, turn of the 20th century. There's no environmental standards, no environmental regs whatsoever. So they're just discharging all that stuff. So there was an old mine in Ledford, basically. Everybody just threw their crap in the creek. You know, they would throw their cans in the creek, and this guy had a refuse pile. And Silverwood Creek was flowing over that refuse pile, and he noticed that copper was plating out onto those cans. Yeah. And there's a huge write-up on this, actually. I have it. And so this guy, he thought, well, if I could just get the water rights for that water. So he approached the mining company and said, can I get your water? And can I get your water rights? And they thought he was crazy. Yeah. They go, are you stupid? And he goes, no, I just want your water rights. I need water. Can I have your water rights? He goes, yeah. So they sign a 3-year lease, right? And he starts cementing this copper out. He becomes a millionaire at the end of the 3 years. And that's when the Anaconda company noticed what he was doing, noticed him, and when that lease ran out, they didn't renew it, and precipitation plants just sprung up all over the place, and the Anaconda company started doing that.
His last name was Lead.
Yeah. So
that's fun.
And so this is the treatment plant that they built for the Berkeley Pit. It cost $11.5 million in 2004. It's right, this is the Berkeley Pit right here. It's right on the high wall of the Berkeley Pit. And it's basically a high density sludge lime treatment plant. They mix lime with Berkeley Pit water, they raise the pH, and all the contaminants drop out as carbonates and oxides. Now they have a special dispensation. They're allowed to discharge their sludge material to the Berkeley Pit, and it actually helps improve the water quality of the Berkeley Pit. So you get kind of a twofer going on there. But they're not treating yet. They're going to wait for the water to hit the critical water level. What they're doing is they're treating Horseshoe Bend spring water, like I already talked about. And so this is one of the clarifiers. They raise the pH of the solution from 2.5 all the way up to past 11, and everything drops out. That green color is actually zinc carbonate coming out. It's one of the last metals to drop out. Zinc is, and zinc is one of the highest constituents in the Berkeley Pit. It was built in 2003. It was online in 2004, and it treats Horseshoe Bend spring water. Horseshoe Bend spring water about 3 to 4 million gallons per day. And there's a lot of issues still working out that they have to work out with this. They have a huge scaling problem, and they actually hire interns every summer to go into these clarifiers with a breaker bar and just chip the precipitates that form along the clarifier. And I actually have a chunk of it. I was going to bring it, but I was kind of late here today. It's called horseshoe bending. You could sit here and just bang that stuff on this table, and it's not going anywhere. It's pretty solid stuff. This is the latest prediction model for the highest point of compliance site, which is the Anselmo mine. And these are real points. The Berkeley Pit filled up really quickly at first, and then as surface area started to get big, it started to fill up slower and slower over time. This was the last reading, and then you can project that out, and there's a surfer model that we use to do that. The latest, we do this once a year at the end of every year, and last year's projection, we, as in we, I mean not me anymore. It's the Montana Bureau of Mines and Geology that does all this work. I just want to make that clear, but the latest they can predict is that the critical water level will be reached in July of 2023, so they have about 9 years. And they have to do a series of run-ups and compliance tests with this facility before it will be up and running. And so they have to be able to be fully operational 4 years prior to that date right there. And so with that, I'll take any of your questions. Hope I didn't go over too much. Oh, is that good, huh?
So apart from the water, the extraction back out of the water, any other the minerals or metals being recycled and generating a profit or a new break-even point?
So copper is one of them. And actually, one of the last things I was did and helped do when I left is the Bureau put in for a grant to actually look at mineral recovery for other minerals in Berkeley Pit water. And so the idea being that you could recover minerals from there and then use the profits off of that to pay for remedy.
So if the iron concentrations are dropping in the pit and the copper concentrations are dropping, where is the iron going?
So it's transitioning from the aqueous phase into the solid phase. So what they're doing, it's basically Le Chatelier's principle. So you think by adding dissolved iron into the water from the cementation plant, they would increase the iron content. But if you use, Le Chatelier's principle and you increase the products or the reactants, you force the reaction to the right, and so there's a bunch of secondary minerals forming in the Berkeley Pit. There's a bunch of iron oxides and stuff like that forming in the Berkeley Pit. And so by increasing the iron content in the water, they force the reaction to form more of those secondary minerals. So all of that iron is going from the dissolved phase into the solid phase, and it's dropping out of the water, and it's at the bottom of the pit. And so it constitutes a permanent removal But the thing that the nicest thing about that though is that with the water quality improvement, there are decreasing the acidity of the Berkeley Pit. Now it takes 2 moles of lime to treat 1 mole of acid. And so if you decrease the acidity by, and they have decreased the acidity by about 25%, that decreases your remedy costs by about 25%. And so they're actually helping themselves by this process more than that way.
Going back to the iron, your graph with the concentrations with that, was it total iron or?
That was
one
dissolved iron. Total iron is doing the same thing though.
So
It's-
dissolved, but iron 2 or
Yeah.
iron 3? Is it
So they're putting
any redox?
it's ferrous iron. So let me.
Okay.
So here's the so their cuprous iron is going into an ion exchange process with
Okay.
ferrous iron. But when they put that in the channel, and they're putting it in this channel, and they're putting it down a waterfall, so it oxidizes when it hits the pit. And so you have all these ferric hydroxides that are precipitating out, and then that's co-precipitating and scavenging other metals like arsenic, phosphorus, and so you just the changes have been pretty phenomenal. I'm excited to get this paper out. Yes, ma'am.
Nick, how did they decide where to put the tailings that they removed from the creek remediation project?
So it's a great question, and it's an interesting story, but I'm gonna go back